Hi, so in this video, we're going to look at how we model motion using displacement and time. In particular, how displacement is different from distance. So in this question, we're told that a girl throws the ball vertically upwards, so that its position, h meters, so h is for height, at the time t, so t is here, and this is the height, is shown in the graph. We've been asked to work out the height of a ball at t equals 0 to 4. So we can read these values off a graph. When t equals 0, 1, 2, 3, and 4, and this is measured in seconds. So you can see when t equals 0, we have 8 meters. When t equals 1, we have 9 meters. When t equals 2, again, we've got 8. When t equals 3, we've got 5. And then when t equals 4, we've got 0. So I've written these down here. Okay, so for part B, calculate the displacement of the ball relative to its starting point at these times. So the key term here is displacement, and displacement involves a magnitude and a direction. The magnitude is the distance, and we need to include the direction. So you can see when t equals 0, we're at 8 meters. And this is our starting point. And we can use S to measure displacement, and we'll measure it in meters. So when t equals 0, we're at 8, so the distance from that is 0. Then when t equals 1, we're at 9 meters high, so that is a positive 1 from the 8. So that will be positive 1 meters. And then when t equals 2, we are back to 8 meters. So even though we've gone up 1 and down 1, we are back to the relative starting point of 8. So that'll be 0 again. And then when t equals 3, we're now at 5 meters, but relative to our starting point, we are negative 3. So from 8 to 5, negative 3. And then for 4 seconds, we started at 8, which is our relative starting point, and then we go down to here. So we've got a total of 8 meters, or negative 8 meters, okay? So now for part C, what is the total distance traveled during the first 2 seconds? Okay, so even though our displacement is 0, you can see we've gone 1 up and 1 down. So our total distance is 2 meters. So for part 2, during the 4 seconds of motion, well, we've got 1 up, 1 down, followed by another 8 down. So our total distance is 10 meters. Okay, let's try question 2. Okay, so for question 2, we're told that a particle moves so that its position y meters at time t seconds is given by this formula, y equals 2t cubed minus 6t. And we've been asked to calculate the position of a particle at time 0 to 3. So we'll substitute t equals 0 into our formula for y. This will give us 2 lots of 0 cubed, so 0, minus 6 lots of 0. So this will be at the origin here. And then when t equals 1, y will equal 2 minus 6. So this will give us negative 4. So here. And then t equals 2. This will give us y equals 2 lots of 8 minus 12. So this will give us positive 4, which is here. And then finally, when t equals 3, we have y is equal to 2 lots of 27, 2 cubed, minus 6 lots of 3, so 36. So that will be here. And then we can finish this off by joining them together with a smooth curve. Okay, so for part C, use your model to predict the position of a particle after 2.5 seconds. Okay, so t equals 2.5. So we'll draw a line from t is 2.5 up to the curve, and then we'll go from the curve horizontally across to the y-axis. So this will give us y is approximately 16.25. And then for part D, comment on the validity of this model. Well, you can see that the model is not valid for when t is less than 0. So we could say it's valid when t is greater than or equal to 0, or not valid when t is less than 0. Okay, let's try one more question. In example 3, we're moving away from the graphs and we're going to look more at the formula, that models the motion. So we're told that a toy car moves so that its displacement from the starting point x meters after t seconds is given by this equation here. So this is what models that motion. We would have to find the displacement of the toy car when t equals 2. So what we're going to do is we're going to substitute t equals 2 into our model. So x will equal 1.5 plus 1.2 lots of 2 squared minus 0.2 lots of 2 cubed. When we work this out, we get 4.7 meters. So this tells us the displacement from the starting point is 4.7 meters after 2 seconds. And for part 2, when t equals 5, again we'll substitute the 5 into our formula, or our model. So this is 1.2 lots of 5 squared minus 0.2 lots of 5 cubed. And this comes out at 6.5 meters. And for part B, write down the range of values for which the model is valid. Well, it is valid when t is greater than or equal to 0. Okay? Well, thank you for watching. I hope you've found this useful. You can download the full lesson and worksheet from my website, mrmathematics.com. Thanks again and take care.